at the intersection here, near the fault line.
Yes, that's exactly where the mineralization should be.
Geologists look for indicator minerals like quartz and iron pyrite, which often coexist with high-grade gold ore.
Modern technology allows for instant chemical analysis, confirming the presence of gold before a single ton of earth is moved.
Precise mapping ensures that the extraction of gold remains efficient, targeting only the most concentrated mineralized zones.
Core drilling provides a vertical map of the mountain's interior, revealing the thickness of the gold veins beneath.
Each core sample is a piece of a puzzle, helping engineers visualize the three-dimensional shape of the gold deposit.
With the survey complete and the gold confirmed, the mountain is prepared for the first stage of heavy industrial extraction.
To reach the gold locked within the mountain, the hard rock must first be fractured using precision industrial drilling. Dozens of deep holes are bored into the mountain, following the specific pattern mapped out by the gold exploration team. Industrial explosives are carefully placed to ensure the rock breaks into manageable sizes for the next stage of gold recovery.
To reach the gold locked within the mountain, the hard rock must first be fractured using precision industrial drilling. In a single moment, the mountain's resistance is broken, exposing the gold ore that has been hidden for millions of years. Once the dust settles, the crew returns to inspect the results, ensuring the rock has been broken into sizes suitable for the heavy crushers. The fractured mountain is now ready to be moved, marking the end of the extraction and the beginning of the gold processing journey.
With the mountain face shattered, the heavy lifting begins, moving tons of gold-bearing rock toward the processing line. Every bucket load carries a wealth of mineral potential, requiring raw power to shift the weight of the mountain.
Efficient collection is key. The loader moves with a rhythmic grace developed through years of industrial practice.
These massive haulers are the lifeblood of the site, transporting the gold ore from the blast zone to the primary crusher.
A single truckload can hold several ounces of gold, but it first must travel miles across the rugged mountain terrain. Consistency in the supply chain ensures that the downstream gold processing plants never stop running.
The collection phase ends here, at the mouth of the crusher, where the large boulders will be reduced to manageable stones.
As the last rock falls, the journey of the gold shifts from the mountain's surface to the heart of the industrial machinery. Reduction begins at the jaw crusher, where thousands of pounds of pressure per square inch are applied to the gold-bearing boulders. The mechanical energy is immense, designed to overcome the structural integrity of the hardest mountain rock.
Conveyor systems act as the factory's veins, moving tons of gold ore per hour through the refinement circuit. The secondary stage narrows the focus, reducing the gold ore further to ensure it can be ground into a fine powder.
Precision screening ensures that only the smallest fragments move forward, while larger pieces are sent back to be crushed again.
To release the microscopic gold particles, the rock must be pulverized into a powder as fine as flour. The combination of steel impact and friction turns the mountain rock into a liquid pulp, ready for chemical separation.
The mountain has been completely transformed. What was once solid rock is now a concentrated gold-rich powder, suspended in water.
To separate the heavy gold particles from the lighter waste rock, the slurry is injected into high-velocity centrifugal separators.
Centrifugal force acts as a filter, concentrating the densest minerals, including gold, at the bottom of the cone.
Continuous washing in the spiral classifier removes the unwanted slimes, leaving behind a clean, high-grade gold sand.
Gravity is the ultimate separator. On the shaking table, the immense density of gold causes it to lag behind the lighter rock.
Experienced operators monitor the wash constantly, fine-tuning the water pressure to prevent even a single grain of gold from being lost.
In these massive settling tanks, the washed gold ore is thickened, reducing the water volume before the chemical extraction begins.
Specialized polymers accelerate the settling process, allowing the factory to recover and recycle the vast amounts of water needed for gold processing.
Efficiency is measured in more than just gold. Recycling every drop of water ensures the mountain environment is protected during the mining process.
To isolate the most valuable particles, the gold slurry enters a centrifugal concentrator, where
by spinning at hundreds of revolutions per minute, the machine creates a force 60 times stronger than gravity to trap every grain of gold. This cycle of spinning and rinsing ensures that the final gold concentrate is highly purified before moving to the chemical stage. Pulsating water beds further refine the material, using gravity to pull the gold through layers of rock and steel.
At this stage, the volume of material has been reduced by 90%, leaving only the most gold-intensive minerals for final processing.
Magnetism removes the last of the metallic impurities, ensuring that only the gold-bearing minerals proceed to the chemical extraction tanks.
Now fully separated from the mountain's waste rock, the gold concentrate is ready for the most critical phase, chemical dissolution.
To pull the microscopic gold from the rock, the slurry enters the leaching circuit, where a carefully controlled chemical solution.
Cyanide is the industry standard for gold extraction. It reacts with the precious metal, turning solid gold into a water-soluble complex.
Oxygen is the catalyst. Without it, the chemical reaction would stall. This intense agitation ensures.
To recover the dissolved metal, activated carbon is added to the tanks. Its porous surface acts like a magnet for the gold molecules now floating in the water.
The carbon travels in the opposite direction of the slurry, becoming increasingly pregnant with gold as it moves toward the first tank. Separation is critical. The waste is discarded while the carbon, now heavy with gold, is sent to the stripping circuit. Under high heat and pressure, the chemical bond is reversed, stripping the gold from the carbon and back into a highly concentrated liquid solution.
Electricity performs the final extraction, pulling the metallic gold out of the liquid and onto the cathodes in the form of a rich, golden sludge.
The accumulated gold sludge is harvested from the cathodes, representing the concentrated wealth of thousands of tons of mountain rock. Extreme heat provides the final purification, burning away the last traces of base metals and leaving behind nearly pure, molten gold. The pour is the climax of the process, a moment where the geological history of the mountain is condensed.
After weeks of processing, the raw mountain ore has been transformed into high-purity gold bars, ready for the global market.
And this is how modern factories produce gold from start to finish. The mountain's treasure is.
Subscribe for more real factory breakdowns.